For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the classifications and general properties of acids. In our last lesson, we learned about several different concepts surrounding the definition of acids. We learned about the Arrhenius definition, the Bronsted-Lowry definition, as well as the Lewis definition. We learned that the Arrhenius definition is the simplest. He stated that an acid is a substance that releases hydrogen ions or protons or hydronium ions in an aqueous solution. We discussed that even though this definition is simple and useful, the other definitions broaden the concepts of an acid and are thus more accurate. In today's lesson, we will classify acids as being either monoprotic or polyprotic based on the number of ionizable hydrogen atoms they possess. We will also group acids as being either binary or ternary according to the number of elements they contain. We will explain the general properties of acids in this lesson. Shall we begin? One way that acids can be classified is by the number of replaceable or ionizable hydrogen atoms they contain per molecule. Monoprotic acids are those that contain only one ionizable hydrogen atom per molecule, or those that can only furnish one hydrogen ion per molecule in an aqueous solution. Some common examples include hydrochloric acid, nitric acid, hydrobromic acid, hydroiodic acid, and acetic acid. The ionizations of hydrochloric acid and nitric acid in aqueous solution is shown here, for example. Polyprotic acids are those that contain more than one ionizable hydrogen or can furnish more than one hydrogen ion per molecule in an aqueous solution. Some examples include sulfuric acid, carbonic acid, and phosphoric acid. These equations show the ionization of polyprotic acids in aqueous solution. Polyprotic acids can be further classified as diprotic and triprotic acids. Acids that contain two ionizable hydrogen atoms, such as sulfuric acid, hydrosulfuric acid, and carbonic acid, are called diprotic acids. Acids that contain three ionizable hydrogen atoms, such as phosphoric acid, are called triprotic acids. Another way that acids can be classified is in terms of the number of constituent elements they have. Binary acids are composed of only two elements. Some examples include hydrochloric acid, hydrobromic acid, hydrofluoric acid, hydroid acid, and hydrosulfuric acid. Ternary acids, which are also referred to as oxyacids, are composed of three different elements. These acids often contain hydrogen, oxygen, and a non-metal. Some examples include sulfuric acid, carbonic acid, perchloric acid, and phosphoric acid. Students, we have just discussed two different ways that acids can be classified. Please explain each of these two methods and list one example of each classification. You may begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. One way of classifying acids is by the number of ionizable hydrogen atoms they contain per molecule. Monoprotic acids contain one ionizable hydrogen atom, whereas polyprotic acid contain more than one. Hydrochloric acid is an example of a monoprotic acid, and sulfuric acid is an example of a polyprotic acid. Acids can also be classified by the number of constituent elements they contain. Binary acids have 2 elements, while ternary acids have 3. An example of a binary acid is hydrobromic acid. Carbonic acid is an example of a ternary acid. Let us move on and discuss some general properties of acids. Aqueous solutions of acids generally have a sour taste. For example, the juice of lemons and oranges is quite sour due to the citric acid. While this type of acid is quite harmless, most concentrated acids are corrosive and poisonous. Therefore, you must never try to identify by tasting them. Another property of acids is that they change the color of indicators, such as litmus to red, phenolphthalein turns colorless, methyl red turns into red, or universal indicator turns red. Acids turn the indicators litmus, methyl red, and universal indicator into red, whereas acids turn phenolphthalein into colorless. When dilute acids react with active metals, such as magnesium, zinc, and iron, salt is formed and hydrogen gas is liberated. As you can see here, when hydrochloric acid reacts with zinc, zinc chloride and hydrogen are formed. When sulfuric acid and magnesium react, magnesium sulfate and hydrogen are formed. However, hydrogen gas is not always produced when acids react with metals. For example, when concentrated nitric acid or hot concentrated sulfuric acid react with copper, nitrogen dioxide and sulfur dioxide gases are produced instead. This is because concentrated nitric acid and hot concentrated sulfuric acid are oxidizing agents. Metals that are very active, such as sodium, potassium, and calcium, react violently with acids. In fact, these reactions are so violent that it is dangerous to perform them. When acids react with carbonates and hydrogen carbonates, salt, water, and carbon dioxide gas is formed. When concentrated acids react with sulfites, sulfur dioxide gas is liberated and salt and water are formed. Acids also neutralize basic oxides and bases or alkalis to form salt and water. This reaction is called a neutralization reaction. One last general property of acids is that they are electrolytes. This means that they conduct electricity in aqueous solutions. Students, let us do an activity to review all of the properties of acids we have just covered. Please complete the following reactions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to complete each of the reactions? Let us go through them together. When acids react with active metals, salt and hydrogen gas is formed. However, there are some exceptions to this. When acids react with hydrogen carbonate, salt, water, and carbon dioxide are produced. When acids react with carbonate, salt, water, and carbon dioxide are also formed. When a sulfite reacts with an acid, sulfur dioxide, salt, and water are produced. When acids react with basic oxides, salt and water are formed. Today, we learned about different ways of classifying acids. We also learned about some general properties of acids. In our next lesson, we will discuss the strength and weakness of acids. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.